Hey, welcome back. Now we want to start working with multiplying rational expressions as well as dividing them. And here we go. So multiplying first. Recall how this worked in arithmetic. Maybe you had something like 10/3 times 21/5. And there's a couple ways you could approach it. One way I see students do it, which isn't going to be very helpful in this context, so I'm kind of showing you the way you don't want to do it, is to just multiply straight across. So 10 times 21 is 210, all over 3 times 5 is 15. Right? And then you got to kind of do some simplification. So in the numerator, you could factor it and get 21 times 10 all over in the denominator, 5 times 3. 21 is 7 times 3, 10 is 5 times 2, and that's all over 5 times 3. And then you could remove the 5s, replace it with 1s, remove the 3s, replace it with 1s. You end up with 7 times 1 times 1 times 2 is 14, all over 1 times 1 is 1, so 14. Okay. It's this part right here which is bad news. This is, you don't want to do, you kind of want to skip this. You don't want to multiply out. So now when you do it, let's take let's revisit this problem, and what we're going to do instead is kind of just jump from here directly to here. Okay. Because what the problem is that you kind of went forward and then you went backwards. You multiplied it out and then you're kind of factoring. So just factor right off the top, right off the first thing you do, right? So 10 is the same as 5 times 2. And then 21 is the same as 7 times 3. And then, you just put all of that in the numerator. And then downstairs you just have 3 times 5. And this is the approach you want to take in this context now with variables. And so the 3's are gone, and you got 2 times 7 is 14, all over 1. And so, yeah, we want to skip this part. Don't multiply out. Just automatically, when you're multiplying, factor, remove, and then simplify. Okay, so that's how it's going to work. So let's take a look at some examples. Sometimes the examples are what they call trivial, like they're so easy, they kind of defy logic. And this is kind of one of those. So it's probably not the best problem to start with, but okay, so this is just straight multiplication. There's really, not going to be any sort of simplification. In the numerator, you have 8 times x plus 5. If you want, you can factor the 8 and the 2 times 2 times 2, but there's not going to be any common factors with the denominator, right? Multiplying straight across x minus 2 times 3, or 3 times x minus 2 if you'd rather. And then you see there's no common factor. So the end answer would be 8 times x plus 5 all over 3 times x minus 2. Okay. It's probably fine to leave it like that. I'm not sure. I haven't looked at my math lab in extreme detail. X minus 6. Let's see if they have one like that and what they would like for their answers. Just really quick. It's probably like number 1, right? Yeah, so this is the same type problem. Let's have a fraction. Now we go 5 times x minus 2 all over 8 times x plus 2. Just to see if they want us to distribute. For me, on a test, it really don't matter. Yeah, they don't even care either here. Okay. All right, so let's move on. So there's no simplification. Let's do one that has some simplification, right? That's what we're here for. So x minus 2 all over x plus 9, and they won't write it initially with parentheses. I just do that to remind you that's one term. X minus 2 is one thing, even though it looks like 2. Right, times 5, x plus 45 all over 2x minus 4. Okay, so again, instead of multiplying this out, instead of like foiling and all that jazz, no, you're skipping that part of it. You're not doing this part where you multiply out. You're automatically factoring everything and putting everything in the numerator from these two guys, so you have an x minus 2 times, and I could factor the 5x plus 5, or 45, right? I can factor out 5, and I'm left with x plus 9. And then downstairs I have the x plus 9, and then the 2x minus 4 is a GCF of 2, so x minus 2 there. And then I can see common factors, right? So I can remove the x plus 9 over x plus 9. I can remove the x minus 2 over x minus 2. It looks like I'm just left with 5 halves. Right? Okay, let's try another one. 9y plus 21 all over y squared minus 2y times y minus 2 all over 3y plus 7. Okay, so you're not FOILing, you're just automatically going to factor the heck out of it, look for common terms, remove those, and then, okay. So in the first, this 9y plus 21, I could factor out a 9 from there, or at least a 3, maybe not a 9, right? So let's factor out a 3. I get 3y plus 7. Then I have times the y minus 2 on the other fraction. Downstairs, I can factor a y out of the y squared minus 2y, so I get y minus 2 there. And then I get the 3y plus 7. And again, you see the cancellation. Right? So that with that, this with this, and we're ending up with 3 times 1 is 3, y times 1 times 1, just y. Let's look at something a little harder then. But actually, in my opinion, the harder ones are easier for some reason. I don't know. But, you know, it's all beauty is in the eye of the beholder type deal. 3y squared minus 22y minus 16. But I don't know, you really feel like you're doing math the bigger the problems get. But these are real easy. The problem's bigger, but doesn't mean it's any harder. Yeah, so anyways, what are we doing here? We want to factor the heck out of it. So that first trinomial, so I'm going to put everything in the numerator. The first trinomial, it's a plus plus scenario, and that's going to be 3y and y. And then I'm thinking 5 and 2, right? So 5, the outer terms give me 15. The inner terms will be 2, so 15 plus 2, it will give you the 17. Okay. Then the next trinomial, so it looks like a plus minus scenario, y and y, so it's 8 and 4, clearly, with the bigger number negative. And then, so we have another plus minus scenario. I'm not 100% sure how to factor this one yet. This is 3 and 8 maybe, yeah. So 3y and y, and then put the 8 with for the outer part. That will give you negative 24. That way, when you add it on the inside, it will be plus 2. So negative 24 plus 2 is negative 22. And then factor these, so this will be a plus minus again. 48 is 8 and 6, but that won't work. So you say 12 and 4, maybe? That seems to work with the bigger number negative, 12 and 4. And then finally, you can remove any common terms from the top and bottom. So 3y plus 2, 3y plus 2. Y minus 8s are gone. And then the y plus 4s are gone. Okay. So you're just going to be left with y plus 5 all over y minus 12. Okay. Let's look at one with the opposites, the sort of opposite terms. So example, 8x plus 2 all over x squared minus 9 times 3 minus x all over 4x squared plus x. Okay, so I can, in the first factor here, this 8x plus 2, I can remove a 2. I get 4x plus 1. And then times the 3 minus x, nothing I could do with that. This x squared minus 9 is a difference of squares, so x plus 3, x minus 3. And then this 4x squared plus 3, I can factor out an x. And I get 4x plus 1. Okay. And then I can start removing common factors. There's opposites here. So the 3 minus x and the x minus 3. And don't forget, when you remove opposites, you got to replace one of them with a -1. The 4x plus 1s are gone, and then I think that's it. So in the numerator, you're going to end up with -2. And the denominator, it looks like we have an x times x plus 3, which you could leave like that if you want. No reason to distribute the x back in. Sometimes it's better just leave it factored. In some of the applications of work, some of the applications where you're doing problems, it's better to have it in that form anyways. So, okay, the division turns out to not be all that big of a deal then once you master multiplication. There's just one extra step, right? So recall doing something like maybe 3/5 divided by 21/10. Okay. So the only extra thing you got to do is replace the division symbol with multiplication and take the reciprocal of the second term. Okay. And then again, we're not going to multiply out. We're not going to say 30 all over 105, right? We're going to factor as we go along instead here in this new setting. And then we can see, all right, these go away, and we're left with 2/7. Okay, so let's look at some of the examples that we're going to be facing in the homework. X over 5 divided by 20 over x. Okay, so I'm going to replace the division symbol with multiplication and essentially flip the second fraction, or reciprocal. Take the reciprocal. Okay. So in the numerator, there's not going to really be any cancellation. You kind of see it if you were to multiply it out and put everything in factor. You're not really going to get any cancellation. Right? Okay, so in the numerator I have x squared, and the denominator I just have 100, and that would be it. Let's try another 4 over x minus 6 divided by, and we'll go through like maybe 3 or 4 more of these, and then I'll hit WebAssign, or MyMathLab. 40 all over 7x minus 42. Okay, so automatically rewrite it as multiplication. And then we're going to factor. So 4, you can factor 4 if you want. I'm not going to bother though. And then I can factor a 7 out of the 7x minus 42, so that'd be x minus 6. Downstairs, I have an x minus 6 and then a 40. I'll factor that as 4 times 10 because I see that there's going to be a common factor in the numerator of 4. Okay, so I'm going to remove the 4s, remove the x minus 6s, and I'm getting 7/10. Final answer. This next one it kind of seems tricky, but it's not. Here we have the polynomial, the trinomial, y squared plus 4y minus 5 divided by y squared minus 25 all over y plus 7. Okay, so how do I handle this? What the heck's going on? Well, you can re-envision this first, the trinomial in this first position at all over 1, right? So if I had like 5 divided by 7, I could rewrite that as 5 over 1 divided by 7 over 1, and then that would be 5 over 1 times 1 over 7. Okay, so what I'm going to do is just rewrite y squared plus 4y minus 5 all over 1. And then I'm going to rewrite the division as multiplication and flip this thing, y plus 7 all over y squared minus 25. And then I can, multiply straight across, factoring as I go here. So the y squared, this trinomial, y squared plus 4y minus 5, can factor into a plus minus. This would be y plus 5, and then minus 1 there. Then we have a y plus 7. Downstairs I'll have y minus 5, y plus 5. And then we can look for common terms. So looks like only the y plus 5 will be eliminated, leaving me with y minus 1 times y plus 7 all over y minus 5. Okay. And I'm fine with you leaving the numerator like that on a test. I'm pretty sure WebAssign is okay with it too. You don't have to FOIL that numerator back out. Okay, let's do one more and then I'll go to my math lab. So 3y squared. 3y squared minus 12 all over y squared plus 4y plus 4 divided by y squared plus 2y all over y cubed minus 2y squared. Okay, so first I'm going to get rid of the division stuff. If you want to, you could factor as you go along. This is the way I do it. So times y cubed minus 2y squared all over y squared plus 2y. Now I'm going to start factoring. So GCF for the first binomial there is 3, y squared minus 4. And then the GCF for this binomial will be y squared. And then downstairs, looks like this trinomial will be plus plus, and it looks like a perfect square trinomial with 2 and 2. And then this last guy, I can factor out a y. I get y plus 2. The numerator isn't completely factored. We have a difference of squares right here, so I need to factor that still. So I have 3 times y minus 2 times y plus 2 times this y squared times y minus 2 all over y plus 2 times y plus 2. Did I miss a sign? Yeah, I screwed up a sign, I think, right here. That's sort of magically. Oh, no, hold on. I did something silly. I gotta find it. Maybe I made a mistake in my notes. Yeah, I copied it down wrong. Yeah, I copied it down wrong. Correct. I'm sorry. Yeah, let me do this again. I also forgot to give you the video quiz question. I think the video quiz question was, I can't believe I didn't write it down. The video quiz question was this guy. This guy's the video quiz. So you may want to pause it and get that copied down for your video quiz. Okay. Video quiz, video quiz, video quiz. This guy, if you allow me to, sorry, I screwed it up. We can simplify it, so it doesn't matter that much. It's just not going to have a nice simplification like we usually do. Y times y times y plus 2. So we get one of the factors of y plus 2 that go away. There's a y squared here. Y squared is the same as y times y, right? So one of the y's will kind of cancel out, and you'll be left with 3 times y minus 2 squared. In other words, y minus 2 times y minus 2. In the denominator, then you'll have y plus 2 squared. Okay. So there's that. Let's go to my math lab then and see what they have for us in terms of difficulty. Or harder problems. They always throw in some hard ones for us. So then, yeah, that looks. Maybe. Let's do this. Maybe. This is so hard. Let's start with this one. As soon as I copy it down on my paper, I'm gonna automatically take the reciprocal. Okay, so I'll automatically write it down on my paper as a multiplication. So xy all over x squared minus 4xy plus 4y squared. Okay. Now I'm going to go ahead and factor as I put everything in the numerator. X squared minus 4y squared is the difference of squares. It's x minus 2y, x plus 2y. And then x minus y. Downstairs, for the first trinomial, looks like it's going to be x and x has to be plus and minus, and we have maybe the big number has to be positive, so 2y and then just y here. And then for this last trinomial in the denominator there, that'd be x and x has to be minus minus, and then 2y and 2y, I believe. Okay. Remove common terms. Well, there's a ton of them. And you're just left with 1 all over 2y, x minus 2y times x minus 2y, or x minus 2y squared, if you'd rather. Okay. So 1 divided by x minus 2y squared. Oh, sorry, folks. What did I do wrong? Plus x plus 2y, x minus 2y. Maybe it doesn't like it, the fact that I put the square there. I can't believe that would be an issue, though. Otherwise, it's something silly that I did. I have no idea what I did. Oh, I just forgot to remove. I must have not crossed it out. And that's right there. So it'd be 1 over x minus 2y. Sorry about that. Let's move on to another one. Sure they have plenty. Oh my gosh. All right. So this one has multiple operations. You have to do parentheses first. Please excuse my dear Aunt Sally. Okay, so let's do that first. 1 squared. I'm just going to be copying it here for an hour. Once you copy it down, kick back and look at it and make sure it's copied right. 9 times out of 10, your mistakes are just going to be from copying things incorrectly. Let's go ahead and rewrite the multiplication then here. So times y squared plus 8y plus 12 all over y squared minus 4. Okay, so I got to factor these inside the parentheses here. You get y minus 2 for one term, and then y minus, y plus, if you'd rather plus minus. 4 has to be, the negative has to be the bigger one. 2 downstairs. Looks like it has to be a minus minus scenario. And then 6 and 4 to give you 10. While I'm at it, I might as well just factor this guy, y plus 6 and 2. Well, 2 over y minus 2 times y plus 2. So you have to do the parentheses first. Y plus 2's are gone, y minus 4's are gone. Leaving me with the y minus 2 over y minus 6 times the y plus 6 times y plus 2 all over y minus 2 times y plus 2. You can write it all as one fraction, but there's no real need to. You can just do your simple, you want to pretend, there, I did it, you know. Y minus 2's are gone, the y plus 2's are gone, and let's just have y plus 6 over y minus 6. So, I mean, they look like they're scary, but they're usually pretty easy, and it just comes down to can you keep yourself from making any mini mistakes. Another one of these. Okay. So 3x squared plus 3x minus 60 all over 2x minus 8 divided by, I have to do the stuff in the parentheses first. Okay, so I'm automatically going to start kind of simplifying a little bit. 18 is 6 times 3. X squared is x times x. And then I have, I can factor out a common factor of x from that trinomial that's sitting there. And then I'll have x squared plus 3x minus 10. So I'm still going to have to factor that thing all over. The x squared minus 7x plus 10 would be x minus 5 and 2, 5x minus 2. And then 15, is 5 times 3 times x times x times x. You can start canceling a little bit if you want. The 3's are gone. I can get rid of all these x's. And you end up with 6. Whoops, and I lost my entire first term. First factor here, this 3x squared plus 3x minus 60 all over 2x minus 8. Divided by, what do we have? 6 times, and I got to factor this x squared plus 3x minus 10 still. Okay, so I get x plus 5, x minus 2, x minus 5, x minus 2. So the x minus 2's will go away, and you're left with 6 times x plus 5 over x minus 5. Then we could rewrite it as multiplication. And then we want to simplify the heck out of it. So there's a GCF of 3 in the first guy. So this guy right here, I can factor out a 3 and I get x squared plus x minus 20. Okay, and then I can factor the x squared plus x minus 20 as x plus 5, x minus 4. Okay, and then we have the x minus 5 from the second fraction. Downstairs, you can factor out a 2, you get x minus 4, and then times 6, which is the same as 3 times 2. Then times an x plus 5, and then we have some stuff we can remove. We can get rid of the 3's, the x plus 5's, the x minus 4's, and what do I got left? So x minus 5 all over 4. And that's nice. X minus 5 all over 4. And I made a mistake as usual. Okay. All right, so I see one mistake I made way back in the beginning. I put 3 x's. There's actually only 2 x's. Okay, so you're still going to have 1 x left in the denominator when you do that cancellation of those. Okay, so there should be an x down here. Then that will carry over to here. Then that will carry over when I flip it. That'll go on the top to here. So that'll be right there. And then that'll be right here. So let's see if that remedies this problem. If not, then there's more mistakes. Okay, so where's the other ones? Oh, I see I lost the 5 in there. So there was a 5 here. So we have to have a 5 there. That'll be a 5 there. I'll put a 5 there. And that'll put a 5 in here. And then, so there'll be a 5 there. 2 mistakes. So only one more. And that time, I have no idea. So I made another mistake somewhere. So I made 3 mistakes. So let me try that again. Let me do a similar question. I apologize. It's like I don't want to write out too much, because, all right, so I'll write it out in all of its gory detail. I guess it's the only way I can do it without making mistakes. All right. Just trying. I mean, that happens a lot. I mean, I see that with students as well. They'll try to take shortcuts. It usually just ends in a nightmarish scenario. So anyways, let's take it just one thing at a time, right? So first I got to do the parentheses, all of this jazz. Okay, so I'm going to factor the heck out of it. I'm not going to worry about factoring the numbers. I have 30 x squared. Then I can factor out an x from this thing times x squared plus 2x minus 8 all over 18x cubed times x squared minus 6x plus 8. Okay. So I have 3x squared plus 3x minus 36 all over 5x minus 15. Divided by, on the numerator, I'll have 30x cubed times x plus 4, x minus 2. Just make sure that's right. Downstairs, I'm having 18x cubes times x, let's be minus minus, so x minus 4, x minus 2. And then we can start simplifying a little bit. 30 over 18 is the same as divide top and bottom by 6, so 5 all over 3. So rewrite the first term, 3x squared plus 3x minus 36 all over 5x minus 15 divided by, so 30 over 18 is the same as 5 over 3. The x cubes will go away, x minus 2's will go away, and then I have x plus 4 over x minus 4. Get rid of the division symbol. And we're multiplying. So times 3 times x minus 4 all over 5 times x plus 4. Okay, so factoring now, factor this. First I could plot a GCF of 3. Downstairs I could factor out 5. And then I got to factor the x squared plus x minus 12. You can shuffle terms about with the commutative law of multiplication. 2 times 3 is the same as 3 times 2, so you can move things. So the x plus 4's will go, the x minus 3's will go. Upstairs I have 3 times 3 is 9, times x minus 4. And downstairs I have 5 times 5, which is 25. And let's see if that works. Arrange everything you want to do this. No, I can't see the answer. So, fraction 9 x minus 4 all over 25. Answer. Hey, I got it. All right, let's look at this guy. It's a multivariable type problem. So I got x squared minus, looks like I'm going to have to do some grouping, plus xy minus yz all over x plus y. I'm going to automatically flip the second term. So I have x minus z all over x plus y. Just rewrite it automatically. Now I can factor everything. So grouping, so factor on x, so I get x minus z. With the second two terms, I can factor a y. And that's all over x plus c. factor out the common factor of x minus z from both of those. So I have x minus z times x plus y, and then from the other fraction there will be a factor of x minus z. And then downstairs I have x plus z, and then from the other fraction x plus y. And it looks like the only x plus y's are going, and you'll be left with x minus z times x minus z, or x minus z squared if you'd rather, all over x plus z. So let's see. X minus z squared over x plus z. Sure. So it looks like multiple variables, some cubic stuff. 5 xy plus ay plus 5xb plus ab all over 25x squared minus a squared times, I'll go ahead and flip it, 35x minus 7a all over y cubed plus b cubed. Okay, so again I need to do a factor by grouping on these. So from the first two, I can factor out 5y, get x plus a. The second two, I can factor out a 5b, get x plus a. Downstairs, I'll just leave everything else for now. Yeah, I guess for me, if I do too much at once, I'll just end up making mistakes. But I don't know, some people can do a lot more, but you'll make, generally it causes mistakes. So anyways, the first two, I'm going to factor out an x plus a, and I get 5y plus 5b left over, and then times this portion, I'm going to factor out a 5 from that junk, and I get 7x minus, whoops, I mean a 7 from all that stuff. And of course, that looks terrible, so I'm going to get rid of that. So let me factor out a 7. Right, 7, I'll be left with 5x minus a. Stairs, this portion is difference of squares, so 5x plus a, 5x minus a. And then this is a cubic, so the a value is y, the b value is just b, little b. So same, opposite, always positive. Let's get y plus b, and then y squared. by, and then b squared. Okay. See if anything cancels, really. 5x minus a's are gone. Oh, you could pull out a 5 from this right here, from this term. Okay, so let me do that. I have x plus a times 5 times y plus b times 7 all over 5x plus a times the y plus b times the y squared minus by plus b squared. So the y plus b's are gone. And I guess that would be about it. So we get 35 times x plus a all over 5x plus a times y squared minus by plus b squared. I hope that's it. Don't seem like it, right? 35 times x plus a. There's a certain satisfaction you get when you get them right, and it feels like there's like no way. Squared minus by plus b squared in parentheses. Nope. So I probably made some little mistakes. Let me pause the video. Oh, I found it already. So it's right here. For some weird reason, I thought it would be okay to factor out a 5y. You can't factor out the 5. Ain't that a bummer? So one little mistake like that. Let me try again. 5xy plus ay plus 5xb plus ab all over 25x squared minus a squared divided by, in other words, multiplied by 35x minus 7a all over y cubed plus b cubed. Okay, so my mistake, I've accidentally factored out 5y from the first two. You can only factor out a y. So I have 5x plus a, and the second two you can only factor out the b. So you get b times 5x plus a, and then down below, I apologize, I'm so sorry. So a all over y cubed plus b cubed. So the first two terms you can factor out the 5x plus a, you'll be left with y plus b, and then times the factor out a 7 from the next portion there, so you get 5x minus a. Downstairs, 5x minus a, 5x plus a, difference of squares. And then a cubic part, y plus b times, same opposite, always positive, y squared minus by plus b squared. And then we can remove our common factors, 5x plus a, 5x y plus b, and then more cancellation probably means it's probably right now. So y squared minus by plus b squared. And let's see if that works. So this is just 7. All over y squared minus by plus b squared. One more. Okay, so now this one is an application. Write a simplified rational expression for the area of the figure. So a rectangle is just length times width. So the area would be the x squared minus 49 all over x squared minus 81 times x minus 9 all over x squared plus 7x. And then, okay, so factoring, I get x plus 7, x minus 7, and then x minus 9 from the other term, and then x minus 9, x plus 9. And then I can factor out an x from this third part, and this part in the denominator, x times x plus 7. And then remove common factors. And it looks like we're getting x minus 7 all over x times x plus 9, which is squared. I think that hopefully that'll do it. So as usual, I appreciate you for watching. I apologize on the last two questions I got wrong. That's not like me. In my self-defense, it's, I don't know, I'm tired. All right, anyways, thank you for watching, and I will see you next time.